Okay, number 21 on page 547. You're thinking of opening a restaurant. You need the average income, right? The mean income to be over 85,000 to support the type of upscale restaurant you wish to open. Take a sample of 50 people and then take the average of their income to see if you should open this restaurant. Okay, now, what is our parameter? Well, our parameter is going to be the mean income of 85,000. Okay, income, right? Now I would probably write a sentence that would go along with that, but I don't want to take the time to do that right now. And then let's see, the null hypothesis is, well, that the average income is 85,000. And then the alternative hypothesis, the one we want to prove, is that the average income is larger than 85,000. Okay, there you have it. Now we're going to talk about the type 1 and type 2 errors. So we take a sample, and the average income is not 85,000. 85,000 would be the average income here. We get a much higher income. So high that we'd be like, well, there's no way that the average income is 85,000 because we pick so many people that make so much more money. Okay, it must be bigger than 85,000. Okay, so what do we do for that? Well, we would reject the null hypothesis in favor of the alternative hypothesis. We're going to reject the fact that it's 85,000 and say it's higher than 85,000. That is a type 1 error. Okay, when we reject the null hypothesis, even though the null hypothesis is true. So we think that people make more money, but they really don't. What's the consequence? Well, you open a restaurant, and it's too expensive for everybody, and you go out of business. All right. Now, that is a type 1. Type 2 would be, well, we get an income that is close to 85,000. Right? And what's the probability that we would get that? Higher than 5% if that's our alpha level. So what do we do there? We fail to reject the null hypothesis. Okay, we fail to reject the null hypothesis, which is a mistake, which means we think that the average income is 85,000, but it's actually a lot higher. What is the consequence? Well, we probably decide not to open our restaurant, and we miss a great opportunity because there were a lot of rich people and we could have had a good time and made a lot of money. Okay, that is type 1 and type 2. These are real thinking problems. And letter C, let's see what that says. So at what significance level would you go with? A 10%, 5%, or 1%? Well, if it was me, and if you're going to make a restaurant like this, it's going to be, $500,000 to open this restaurant. It's a lot of money, and it's a lot of risk. So I probably would go with a 1%. I want to be really, really sure that these people make enough money to go to my restaurant. That's what I would do. Okay, and that's how I would justify it. If it's a very low alpha level, it means that you really want to make sure that you're making the right decision. Okay, next. Okay, here we are on page 597. Let's try this practice test. So you should read the question and try it first before continuing this video, but let's do number 1. Assuming that you gave it a shot. This was pretty straightforward, I think. So let's see. Banning handguns. Now, a commentator thinks that more than half of the adults favor such a ban. Okay. The null and alternative hypothesis. We've done a lot of these. So the null hypothesis, remember, let's see. Well, this one's out because it's dealing with p hat. This one's out because it's always equal to. The null hypothesis is always equal to. And now we can take a look at, well, we are either going to be bigger than, less than, or not equal to, and the commentator thinks it's going to be bigger than. So, answer has to be letter B. No change would be 50% of the people favor this ban. The alternative hypothesis, which is what we're trying to prove, is that more than 50% of the people favor this ban. There we go. There's number one. Okay, so you read this and gave it a try. Let's see if we get the same answer. You are thinking of doing a one sample t-test, so that's with means. Population mean, 0.05 significance level. The population is not normal. Okay, that could be a problem. So, what are we going to do about that? You should not carry out the test because the population does not have a normal distribution. No. You can safely carry out the test if your sample size is large and there are no outliers. That seems like it's the right one. You can safely carry out the test if there are no outliers regardless of sample size. No, that's not true. You can carry out the test only if the population standard deviation is known. That's rarely true. T procedures are robust, so you can use them anytime you want. No, that's not true. So the answer is letter B. Remember, you can have a little bit of skewness, but the outliers really mess everything up. So, or, of course, if the sample size is 30 or more, you should be good to go. All right, there's that one. Okay, this is kind of a tricky one. So, null hypothesis is that they're innocent versus the alternative hypothesis is that they're guilty. So if we make a type 2 error, that is, we fail to reject the null hypothesis by mistake. Fail to reject the null hypothesis by mistake. So in other words, what we're saying is that we're saying that they're innocent, but they're actually guilty. We are saying that they are innocent, right? Examiner's decision is innocent, but the actual true status is that they're guilty. So here, right here, that's a mistake. The examiner says that they're innocent, but they're actually guilty. So out of all of the guilty people, right, they made a mistake 15 out of 140 times. That's what they could do. So 15 out of 140. 15 were mistakes out of the total that they could have gotten right. Right there, letter C. There you go. Number 4. So you do a significance test, and it says, yes, you can reject the null hypothesis at a 5% significance level. Let's see what that looks like. So like this, right? We got our graph, and we're like this, and here's our 0.05, and we say, well, the results we came up with would happen less than 5% of the time. So we're suspicious. Now, can we automatically say that they would also come up less than 1% of the time? Not really. We could have a p-value of 0.032, right? That we would reject at 0.05, but we would not reject at 0.01. We don't know. So if we go through these answers, you come up with all these different things, and really we just can't tell. It's letter E. The answer can't be determined from the information given. Yes, we might be able to reject at a 0.05, but that doesn't say that we can automatically reject at 0.01. We just need more information. There you go.